Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy, variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Recurlicursion and it's by Ungesundheit. And here are the rules. We have normal Sudoku rules apply, which means fill the grid with the digits 1 through 9 so that none repeat within a row, a column, or a box. Digits along a thin gray palindrome line must read the same forwards as backwards. So for example, this could be 1, 2, 5, 2, 1, and it reads the same forward as it does backwards here. So that's how palindrome lines work. We also have cells connected by a V sum to 5. All V's are given, so this is a negative constraint, which means that if there are two digits which are adjacent that share an edge with each other and they add up to 5, they are marked by V. If there are no digits here aside from the ones that are marked with the V, between them, that share an edge with another number that adds up to 5. And that's what the negative constraint means. So for example, if this were a 3, this would have to be a 2. If this were a 3, 2 cannot share an edge with it because we know all the V's are given. So therefore, there cannot be a V here. Therefore, a 2, if this was 3, this could not have a 2 in any of these cells that share an edge with it. We also have cells connected by an X sum to 10, and not all X's are necessarily given. So while all V's are given, not all X's are necessarily given. So we do not have the negative constraint for the X's. We do have the negative constraint for the V's. And the negative constraint just means that if something isn't there, we can assume that it cannot add up to 5, right? Because it can't. The negative constraint is not fulfilled. The constraint is not fulfilled because there is no V there. But for X, there is no negative constraint. That's what we usually mean by when we say negative constraint in the variant Sudoku community. We also have cells connected by a white Kropki dot have adjacent values. So for example, if this were a 6, this would have to be a 5 or 7 to make sure that these digits are consecutive. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's learn how to Sudoku. Okay, so what I like doing, particularly in the VX spaces, is I like basically coloring. Well, I like coloring specific digits, but I think on this one I will start coloring low and high digits right now, for now. So the low digits have to be blue. So those are the digits 1 through 4. And the only digits that can add up to 5 are 1 through 4. So these are low, 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 and these are low. We know that for certain. So on an X, if you have a low digit on one side, which is the digit 1 through 4, it must add up with another digit, which is high, which is the digit 6 through 9 on the other side, right? So 1 and 9 add up to 10, 2 and 8 add up to 10, 3 and 7 add up to 10, 4 and 6 add up to 10. Therefore, this digit is high. This digit is the same as that digit, so this has to be a low. We have this digit is the same as this digit here, so this must be low. 1, 2, 3. So this is 1, 2, 3, the same digit as that. 4, 5. This is 4, 5, so this is also a low digit here. And we can mark all the low and high digits here. In row 4, we have 4 low digits, so the rest have to be high or 5. So this has to be a high because 5 can never be next to an X. Because if you try to add 5 to another digit to add up to 10, what is it? It has to be 5, and you'd have a duplicate 5 in the same row. So since this is high, this has to be low. We have 1, 2, 3, 4, 5. So this must be 1, 2, 3, 4, 5. Which means in this central box, we have 4 lows. Which means the rest of the box must be high or 5. We're not sure which. So these 3 must be high or 5. Which makes these 3 high or 5. We have 1, 2, 3, 4, 5. This is 6. So 1, 2, 3, 4, 5. So this is also low. This is higher 5. We have 4 lows in the upper left-hand box, which eliminates lows from the rest of the box. So this must be higher 5. We have in column 6, 4 lows, so the rest are higher 5. We have in row 8, 4 lows, so the rest are higher 5. Okay, what else do we have? 3. So these must be higher 5 in row 4. Row 5, we don't have anything yet. Row 6, no. Row 7, no. Row 8, we have it. Row 9, we have it. Row 1, column 1, column 2, column 3, column 4, column 5, column 6. Column 7, we don't have anything. Column 8, we don't have anything. Column 9, we don't have anything. Okay, boxes, we've already... Okay, so in the lower central box, we have 4 low digits. So this must be high and 5 in the rest of that box. Okay, so let's start coloring what we know, right? So we match these to these, low, low, higher 5. That works. Okay, so this is low, which matches that. Low, low, higher 5, low, higher 5. We don't have any information here. No information. This is higher 5 here. And these both must be low, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is low, which forces this to be high because it adds up to 10 with a low digit. Therefore, this must be high because it's the same digit. These digits are the same. Okay, what else do we have? Okay, so this digit is the same as this digit, and it cannot be this digit because they see those digits in those gains. So this digit, okay, so we're going to mark this with an A, I guess. So we're going to make this A. This matches this A, so one of these must be an A here. This we're going to mark with a C. It must match with C here. Oh, so then where is it? Right, this matches here, so that's the third digit. This is the third digit. This must be a C here. A and B, let's make this B. So this must be an A-B pair, because these add up to 5, these must add up to 5, and this is we're going to mark as D. That means B has to be one of these digits here. This also must be a C. C adds up to 5 with only D, so this is D. This can't be C or D. This is A or B. This can't be C or D. It can't be A. This must be a B here, which means this can't be A and B adding up together, so this is C or D. This can't be B anymore. This has to be A then. So normally I would color these, but it's easier to see the low digits here. I don't know. Maybe. Okay, so let's mark all the Let's mark all the low digits as 1 through 4. That's maybe it'll make it easier to spot everything. And then we're going to mark the pink digits as 5, or the pink possibilities as 5 through 9. And then we can remove all the colors there. And then we're going to mark these as 6 through 9. So what we're going to do is we are going to color each individual square. And we're going to mark them as high and low digits. So this will mark as blue and orange. And these we're going to mark as pink and green. So again, this matches this one. So this is orange here, which means this can't be orange because it's the same as that one. It has to be pink then, right? Because it cannot be the orange one. So this is pink. This is orange. This must be an orange-blue pair. So this matches this digit, so it's blue. This matches that digit, so it's pink, which means this has to be green to add up with the pink to add up to 10, or to 5. This is the orange digit, because that's the only digit remaining. This has to be the pink digit. This is the orange low. So we match, this is the way I like doing actually anything with XVs, where you know all the Vs are given. You know these must match, because these add up to 10. This cannot be, this can't be pink, orange, or green, so this must be blue, which forces this to be a blue high. This is blue. This cannot be blue high here because of this blue. So this must be orange high, which means this matching orange. This can't be orange. This is blue. This has to be the blue high to match that. Where is the blue low? We don't really know. This cannot be, let's see. This can't be blue or orange high, so it's green or pink, which means the other green or pink must be here, which means this must be blue and orange. This can't be blue-orange pair, so this is green or pink. This is green or pink, but it cannot be pink because of the pink low already in the column. So this is the green, which means this can't be green. This can't be green. This is pink, which makes this the green low. Okay. Orange. So where's the orange low in row 1? Can't be here because of the low orange there. Can't be here, and these are already counted for, so this must be the low orange here, which eliminates low orange from being this cell, so this must be the low blue, which means this is low orange. Low blue, where is the low blue in this central top cell? Cannot be here, cannot be here, cannot be here, so it must be here. So this is the low blue in this central top box. Orange. So where is the orange in column 3? Can't be here because of the low orange in the rest of the box. Same here. So it can't be these two, so it must be here. So this is the low orange in the column 3. We have 8 low oranges. We know where the last low orange has to be. It has to be here. This is low orange there. Now we're looking at low blues. It has to be one of these two. Okay, and we don't know which. What about low greens? it must be one of these 2 digits. And we also know, did we know anything else? We don't really. Never mind. Low green's one of these. Low green has to be one of these 4. It can't be one of these 2. Okay. So where is the low green in this right central box? Cannot be here because we see, actually, these are all 5 through 9 remaining in column 7 because we have 4 1 through 4s already in column 7. So this is 5 through 9. Therefore, the low green has to be one of these 2 digits, which means low green cannot be any of the rest of row 6. And that also is a 1 through 4, which means this can't be 1 through 4. This is 5 through 9, and it matches that. Therefore, the low green in column 2 cannot be any of these cells because of the low green in the box. Can't be any of these cells because of the low green in the box. Can't be either of these because they're not low. So this must be the low green here. Since this is the low green, where is the low blue in this box? It cannot be here, and none of these are allowed, so it must be here. So this is the low blue, which means we have 4 low digits in row 5. That leaves 5 through 9 in the rest of the box. This is a high orange because it's next to a low orange. This we don't know. This is either high green or high pink. Okay. This is the same as that digit, so this has to be 5 through 9. Which means this is the low green here. Since this is low green, this can't be low green. This is low pink, which makes this low green here, which makes this high green. Okay. We're still missing a high blue, a low blue in column 2. But low blue cannot be next to a low orange without a V in between. So this can't be low blue. Therefore, this must be low blue here. Which means this can't be 1 through 4 because we have 1 through 4s in column 2. This is 5 through 9. That leaves in row 9 digits 5 through 9. Because we have 4 1 through 4s in that row. Pink has to be the remaining digit here, and it's a low pink. We have a low blue in one of these digits, and it cannot be here because of the low blue there. Therefore, this is low blue here. Okay, so this is 5 through 9, 5 through 9, 5 through 9, which matches this. This is 5 through 9. We are looking for a green one low, and it cannot be here, here, or here, so it must be here. So this is a low green. We have all 1 through 4s in row 2, so this must be 5 through 9. Make this 5 through 9. In row 3, we're missing a pink 1 through 4. Cannot be here, so it must be here. This is pink 1 through 4, which means the rest of the box has to contain 5 through 9 because we have all 4 1 through 4s in that box. This also must be 5 through 9. Okay. So we have all of these. Okay. Does that tell us anything? Not particularly. These are the same digit. It must match one of these. We don't know which. So unfortunately, this full coloring actually doesn't help too much. So let's... Because the problem is that the low digits are helpful because we know all of these are given. And this is why I was a little hesitant to basically color the all the digits because it's not very helpful for the high digits. It's very helpful for the low digits so we can distinguish between all of them. But it's not helpful for the high digits because there is no negative constraint. And this is only very useful for the negative constraints, really. Um, okay. Okay, these colorings are good. Let's start labeling letter-wise where these palindromes what these palindromes are. So we're gonna make this A, B, C, and D, which matches. This is A, this is B, this is C, and this is D. So has to be E. E is also here. Where is E in this left central box? Cannot be here, so this must be E here. D, C cannot be here or here. Okay, so this is E. Since this is E, it must match this cell here. So this is E here. We're missing A and D here, so we're not sure which one is which. A and D have to be either of these. 1, 2, 3, 4, 5, 6, 7. That's 1, 2, 3, 4, 5, 6, 7. So this cannot be D because D is here. So this must be A, which means this can't be D. This is A. So this has to be D here, which makes that D there. This, we don't know. It's either... Okay, so... So this matched 4, 5, 6. Oh, wait. Yeah, so this is... Since this is E, it matches 1, 2, 3, 4, 5, 6. So this has to be E. Where is E in column 4? Cannot be either of these. Can't be any of these because that's an E in the box. Can't be here because that's an E in the box. So this must be E here. Since this is A, B, D, and E, this has to be C remaining. So we have the fourth digit here. 1, 2, 3, 4 is C. So we have A and C here. This has to be B then because of the remaining digits. We're missing that. B is here, so B cannot be this one. So this must be B, which makes this a C. So all of these are the same digit. It cannot be, it has to be the blue, and it's not 5. So that's C. We have A, B, C here. This has to be D. Okay, well, maybe we should color these again because that might be helpful to disambiguate. This is blue. So this has to be C here. So this is C, this is C, which means one of these is C. We're not sure which. In column 7, we have A, E, D, and C, so this must be B. So B is the orange, is the high green. Okay. B cannot be here. B is one of these two. Okay, where is the B in this upper central box? It cannot be here. Can't be here, here, or here. So this must be the B here, which makes this a D because that's the only digit remaining. B again is high green. D has to be high pink. Okay, so now we have A and E remaining. We're not sure which one's A, which one's E. We have C, D, and E here. B cannot be here for this cell, so this must be A. And we don't know the difference between A and E. Since A is here, where A cannot, in the upper right-hand box, A cannot be here, 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 or here, so this must be A here. A cannot be here or here. Can match any of these. Okay, so we are left with just D here. D has to be pink. So this is not 5, and it's pink. We have A, B, and D, and C accounted for, so this is an E. That leaves this as C. C is, again, not... It's blue high. That leaves this digit as E. E is here. A, C, and D, so this must be B here, which is not a 5. It's the high green. Where is the high green in column 1? Can't be here because of the high green there. Can't be here because of the high green here. These are filled, so this must be the high green. And is B. We have 8 high greens. We know where the last one has to be. It has to be here. So this is the high green and is B. We have C. This is an AD pair here. We have AD, AB, and E here in column 3. We're looking for C and E. This can't be E because of the E in the row, so this must be C, which forces that to be the high blue. And this can't be E. This must be A. So A are the high orange. So E has to be the 5. So E is 5, which means 5 cannot be here. 5 cannot be these or this. This must be a 5 here. So E is 5. 5 is consecutive with 6, which is the high C. High C then must be 6. And the last one actually can't be here, can't be here, can't be here. Must be here. So this is high C. That leaves this cannot be high A or B or C. So this must be high D, which is orange, or D is high orange. And this is A, which is... no, this is not high orange. D is high pink. And A is high orange. Okay, so C's have to all be 6s. And we can remove the blue from that. The low blues are then 4. 4 must add up to 5 with the low oranges. So the high oranges, which are A, must be 9. Okay, this can't be high orange here, so this is A. And high orange. This must be then high pink, and is D. So high orange again has to be has to be 9 to add up with the 1, which is so the 9s are removed. We have the other oranges, which are 1. This is consecutive with 9. So the high pinks, which are Ds, must be 8. So we can remove the pinkness. That means the low pinks are 2. And the low greens are 3. So the high greens, which are B, must be 7. So then these are 3. And that's how you solve it. I don't know if I would consider this very easy. This is probably more the easy scale for me. There's still a decent amount of knowledge you need. Excuse me. So I would not consider this a very easy puzzle. It's very easy for me, but that's because I've done these puzzles a lot. I've done palindrome and XV puzzles a lot. So I would not consider this very easy, but hopefully I gave you some ideas on how to essentially approach this type of puzzle. And I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.